Hi and welcome to a demonstration of the great new features coming with 3DEqualizer4 Release 4. Introducing network calculation, 3DE4 Release 4 provides an impressive improvement for parameter adjustments shown in this demo. In the next steps, parameters, focal length, and distortion degree 2 will be adjusted. So, parameter adjustment will be added to the display area. After that, both parameters do the pane. Good. Next, the adjustment. The calculation procedure begins and after some time finds the best values. Now, with just these two parameters, it is done in an appropriate time, but more complex calculation will take a lot more. Network calculation, which can be activated with toggle button Network Calc, uses the power of your network and distributes all calculation tasks to all CPU cores available. Activate it, and we see the text field beside change its label. It basically shows how many cores and hosts are available within the network. In this demo, there are 77 cores to speed up the calculation procedure dramatically. With calc method brute force set, the adjustment speed increases linear to the amount of available cores, so it's truly multi-threaded and really the more the better. Okay, clear the view before starting the adjustment procedure again. The same structure appears as before, but much faster. So fast I hardly could finish the last sentence. As we can see, the text field does not just serve as an info about the amount of cores and hosts, but also shows the network's workload by the green bars. One interesting fact, network calculation isn't limited to lens parameters. It can be used for every curve calculation within 3DE4. For experts and administrators, 3DE provides several options for this feature. They can be found in Preferences, after scrolling down to item Network Calculation. First, there's turning Network Calculation off. Note how the client is disconnected and this setting overrides the toggle button. Of course, there's also Enable it. It is recommended to use option Dynamic Self-Organizing Network. Second, slider Allow for Network Calculation defines how many cores of our own machine can be used by other 3DE clients for their adjustments. Feel free to allow as much as possible. It's for your colleagues. Release 4 provides for the first time an interesting set of Python scripts for parameter adjustments. Even so interesting, it got its own menu within the main window. Let's have a look at menu Adjustment. We see different scripts for tasks like adjusting distance constraints, optimizing the interocular distance curve, adjusting survey point positions in 3D space, and optimizing zoom curves of secondary stereo cameras. For this demo, script Adjust Multiple Survey Points will be demonstrated. Let's say we have surveyed data of a set, but some intern messed up everything and misplaced an object, in this case the monitor, right before shooting the scene. Damn you, intern. Obviously, the survey of that specific object is correct, just its position and rotation are far away from its surveyed position. How to fix this? All points which should be adjusted are selected and will be modified with script Adjust Multiple Survey Points. A new requester opens, providing several options like if translation and rotation should be adjusted, as well as their respective ranges. At first, maybe it's sufficient to adjust the positions alone within a range of -50 to 50 centimeters. Quite a huge area, but we really do have messy points. Okay, and we see the script added the 3 parameters from the requester to parameter adjustment. As easily seen by the orange colored labels, they have a different appearance as the existing predefined parameters, which are colored white. Now it is possible to adjust any parameter or object attribute in 3DE4 by using Python, making it the most versatile system for adjustments. How does it work? Behind every parameter or attribute that should be adjusted is a script, and all parameters needed for the respective script are passed to it by these text fields. In our case, there are 3 parameters, each adjusting a single axis of the selected points. In their respective text fields, the axes and points are defined, which are handled by said scripts. Alright, next the adjustment. Adaptive all for a faster calculation. We notice this calculation has the same look and feel like a normal parameter adjustment. The procedure creates samples within the defined range around the initial point positions to find out where they really belong. Seems it was improved quite good. The points are close to their correct positions, but it is obvious rotation has to be adjusted as well. First, clear the parameter of the previous calculation from parameter adjustment. Then again, adjust multiple surveyed points has to be opened. Rotation parameters will be left activated, as well as range will be left untouched since the position isn't that bad anymore. Here we go, 6 little parameters are ready for duty. Again, adaptive all and adjust. Network calc can be used here as well to speed up the adjustment procedure. Nice how much the procedure improves the deviation, resulting in correct position survey points. There it is, very good. Job done. .3DE4 Release 4 presents brand new features for plane line constraints demonstrated in the next steps. Okay, a given project with features tracked just on the floor. 2D tracking is good, we can calc the project. Now, in 3D orientation controls, we see the reconstructed 3D points aren't plain on the floor. The point cloud is inclined and even seems to be bended. The standard procedure, aligning 3 points to exact plane, won't work here, so we need something different. All points have to be pushed to the ground along their individual y-axis. So all points will be selected, and in tab Points in the attribute editor, option menu Survey Type can be found. Type has to be set to exactly surveyed. Well, that's bad. All points move to the origin since their values in all axes is 0. Since release 4, we are able to handle each axis of an exactly surveyed point individually with parameter position x, y, z. Each text field defines an axis of the point. So just deactivate the first and last toggle button. Y-axis should be set to 20. Alright, all points are above the ground, but their individual x and z values remain unchanged. Quite cool. Of course, they should be on the ground. One info, within the object browser, these points are now labeled as Survey Y. Finally, calc all from scratch. And as we can see, all points remained on the plane, but were adjusted a bit along axes x and z. And camera was aligned properly to the new reconstructed point cloud. Approximately surveyed points can be refined in Release 4 far better than before. If this survey type is selected, we see within tab Point a text field labeled Approximately Survey Radius. Demo time to find out what it does. This feature allows 3DE4 to adjust the points positioned in 3D space within the set radius, preventing it from moving around too far. Starting with a value of 15 centimeters, the calculation process now has the opportunity to find a better position for the reconstructed point within the set radius. calc all, and we see the point is now far away from the locator, its previous position. But since it should be just a bit around the locator, we need to reduce the radius. So try a value of 2, calc all. The point moved again, but this time not so far, just as we wished. It's a great tool for enhanced control over the point's position. This demo is all about the update considering distance constraints. It is especially useful for projects with low parallax, when it is quite hard to reconstruct all points correctly. The point cloud is deformed and in many cases may look like a strange worm. Not very nice. Having the ability to create multiple distance constraints improves chances to solve this problem, since 3DE4's calculation process has more hints about the relations of points in respect to each other. So, demo time. First, 2 points have to be selected. Trying to create a distance constraint, we notice menu item Create Distance Constraint cannot be found within Menu Edit anymore. Distance constraints got their own menu, but no problem, creating a constraint can be done here as easily as always. Here we go, a dark line appears between the 2 selected points. Also business as usual. Now what's new? Select 2 different points and create a second distance constraint. We do have 2 individual constraints which did become editable objects. Both constraints can be selected individually. Since they are now objects within 3DE4, they of course also appear within the object browser. Further, a script was added to modify them. Constraint attributes. At first, have a look at toggle button Constraint Active. This option allows us to disable a constraint, so it is necessary to delete it if it shouldn't be included into the calculation process. Alright, with this distance constraint still selected, enable it again, this time through the context menu in the object browser. Good. Next, this constraint has to be actually modified. Value distance has to be decreased to, let's say, 22 centimeters. Okay, and we see the entire point cloud was scaled. But since the point cloud was just scaled, its point relations should be corrected by calculating all from scratch. The point cloud expanded, more along axis Z. Everything looks good again. One more test with a higher distance value. Constraint attributes. This time it is 37 centimeters. Calc all. Here we go, all point positions are correct again. The point cloud was compressed according to the new distance value. Last item to present here, distance constraints can be of course deleted like any other object within 3DE4. Welcome to 360-degree Sphere Maps Wonderland, where everything looks awesome, but nothing can be tracked. So far. In this demo, we focus on sphere maps in 3DE4. Let's import a 360-degree shot. In this case, we see a backyard. Looks nice, but it would be even nicer if this shot can be used to reconstruct this backyard. Let's do this in 4 steps. Step 1. Remove any hashes from the pattern. Step 2. Set the frame range to, let's say, 100. Step 3. Expand list item long LED conversion. We see some parameters which will be demonstrated in the next steps. But at first, step 4. Enable button long LED conversion. The view changed. We zoomed into the picture and see just a part of it. Further, it doesn't look distorted like before. In addition to that, the frame slider changed as well and has 100 frames just like we defined previously. Okay, change parameter resolution to a full HD resolution, just so it looks more cinematic. Then go through the sequence. It seems we now have a nodal pan shot filming the backyard. Basically, that's it, and we are able to track features in order to reconstruct the set. But let's have a look at the other parameters in the attribute editor, which give us more control over the appearance of the shot. At first, let's modify the focal length of the camera by using the slider of parameter, horizontal angle, focal length. Next, with parameter panning, we can define how much our camera should rotate, therefore how much of the shot will be displayed within the set frame range. Both values describe the start angle and end angle. Last, parameter tilt angle lets us tilt the camera up or down. This demonstration focuses on the updated and extended dynamic lens distortion calculation. In the next few steps, it is shown how to create a lens with distortion driven by focal length and focus distance, which is especially useful for anamorphic shots. In this case, classic grid shots with known focal length and focus distance values are being used. Their parameters are, for the first shot, 24 mm and 3 feet, for the second 50 mm and 67 feet, and for the third 105 mm and 28 feet. Alright, next for each grid shot, the matrix has to be adjusted to the checkerboard. Perfect, time to get to the calculating part. In tab Lens, we see option menu Dynamic Lens Distortion. It contains the already known options static, driven by focal length only, and driven by focus distance only. And now as well, driven by focal length and focus distance. Next, Calc Distortion Camera Geometry should be opened, and we see both text fields for parameter keyframe are enabled. But before the calculation actually starts, a new tool has to be introduced. A Python script called 3DEqualizer4. We see a new window containing a grid in a 3D space, sliders, buttons, and text fields. A note for the coders among the viewers: since release 4, 3D objects, like this grid, can be programmed within Python scripts. Quite cool, right? Back to the topic. Navigation works as usual. All axes of the grid, of course, can be modified using both text fields. Changing the range values will change the grid accordingly. Axis X displays focal length, whereas axis Z displays focus distance. Moving the slider knob will change the range of axis Y, displaying a distortion parameter. Good, the basics are explained. The rest will be shown later in this demo. Next, calculation. Calc Distortion Camera Geometry. Be sure the first reference camera is selected. Then Calc Lens Parameters. Create keyframes and close. And here we go. A sample point was created within the 2D lookup table. This point can be selected and, if needed, modified along all three axes by using the handles. But this won't be necessary for this point. So, what does this point describe? It represents the calculated value for parameter distortion degree 2 placed on axis Y. The position on exact plane is defined by the values we set in the reference camera. Okay, the other two grid shots are waiting to be calculated as well. Again, Calc Distortion, second camera, Calc Lens Parameters. Create keyframes, and a second sample point was created. Last, calc the third camera. Create keyframes and close. Now there are 3 sample points representing a distortion value for each reference camera. We slightly can see that all 3 points are placed differently on the y-axis, since all of them have different distortion values. Decreasing the range leads to a better view at the surface. The grid is deformed according to the keyframes we calculated. Of course, distortion degree 2 isn't the only distortion parameter we are able to display here. Select different parameters in the list below to view the grid for each parameter. The last feature of this script to be demonstrated is adding and deleting samples from the grid. Like smoothing a curve using tangents within the curve editor, here it is possible as well to form the shape of the 3D surface in order to smooth it. In case of flawed calculation results, or if manually added points however are needed, sample points can be removed as well.